In this video, I will be synthesizing Congo Red, an azo dye which is blue in strong acidic medium and red in neutral and basic medium. Congo Red is made up of two precursors, benzidine and naphthenic acid. So first we have to prepare these two precursors. Benzidine can be synthesized from hydrazobenzene via benzidine rearrangement, and hydrazobenzene can be synthesized by reduction of nitrobenzene in alkaline medium. Naphthalenic acid can be synthesized from alpha-naphthalamine via sulphonation, while alpha-naphthalamine can be synthesized from alpha-nitronaphthalene via reduction in acidic medium. Alpha-nitronaphthalene can be prepared from naphthalene via nitration. So to start things off, I start with making alpha-nitronaphthalene from naphthalene. For that, I set up a flat bottom flask in a cold water bath with magnetic stirring. To it, I added 5 ml of concentrated sulfuric acid, then I added 4 ml of 70% concentrated nitric acid, dropwise with stirring. Thus, nitrating mixture was prepared. Now to this, 5 gram of powdered naphthalene was added in small portions. After the addition was complete, the mixture was heated on a water bath at 50 to 60 degrees Celsius for 1 hour. The stir bar was stuck in tar. Then the reaction mixture was poured in ice cold water. The stuck mass in the flask was melted and transferred in the beaker and stirred with a glass rod. After solution cleared a little bit, the crude alpha nitronaphthalene was filtered off and washed with distilled water and dissolved in 95% ethanol. I heated small amount of ethanol and to it I added alpha nitronaphthalene. Then I added more ethanol. The ethanol was in excess, so I transferred the solution into a bigger beaker and then filtered the solution while hot through gravity filtration. Some solid is precipitating in the conical flask. So I placed the conical flask on a spirit lamp and started heating it. Now I added 7 ml of distilled water to it. Is of 90% ethanol. This will precipitate any tar that is there in the solution. I removed the tar by decanting of the liquid. Solution to 0 degrees Celsius and yellow crystals of alpha nitronaphthalene were formed. I filtered these crystals using vacuum filtration on my Buchner funnel. It still looks a little impure. The final yield was 2.5 grams, which corresponds to a percentage yield of 37%. I again tried making alpha nitronaphthalene. This time I poured 5 grams of naphthalene powder in a flat bottom flask and added 10 ml of concentrated sulfuric acid and stirred. Now I placed it in a cold water bath and added 5 ml nitric acid dropwise, but this time a lot of tar was formed, so I discarded this reaction mixture. Again I measured 5 grams of naphthalene, but this time I decided to use a solvent to provide uniform nitration, which was acetic acid. So first I prepared the nitrating mixture by taking 3.5 ml 70% nitric acid. To it 3.5 ml of concentrated sulfuric acid was added dropwise. In the previous runs, I learned that using excess sulfuric acid will lead to the formation of tar. So this time I used only equivalent amounts of nitric acid and sulfuric acid. Then I took 15 ml of glacial acetic acid in a beaker and then to it I added 5 grams of crushed naphthalene powder and stirred it. The naphthalene did not dissolve in acetic acid, so I decanted off 10 ml of acetic acid and transferred the suspension in a flat bottom flask. The decanted acetic acid was used to transfer the stuck naphthalene into the flask. Then I placed the flask on a magnetic stirrer and placed a stir bar in it. Then I placed a pressure equalizing addition funnel and poured the prepared nitrating mixture into it. Then stirring was turned on and the nitrating mixture was dripped in it slowly. After some time, the mixture became yellow. After all the nitrating mixture has been added, the flask is placed on a water bath and heated to 60 degrees Celsius for 1 hour. The naphthalene is now getting nitrated at the alpha position, that is the first position. There wasn't any formation of tar and the reaction mixture was yellow colored. Then I poured the reaction mixture into 100 ml of ice cold water with stirring, where alpha nitronaphthalene separates out as yellow solid. It was kept for some time for the aqueous layer to clear up and then filtered off via vacuum filtration. It was washed with distilled water a couple of times to remove any adherent acids. This is the crude alpha nitronaphthalene. The final yield of crude alpha nitronaphthalene after drying came to be 6.75 grams, which corresponds to a percentage yield of 100%. I also measured its melting point and it came around 56 degrees Celsius, which is very close to reported melting point 60 degrees Celsius. So I didn't bother to recrystallize it as recrystallization would lead to loss of product and the crude is sufficiently pure for next reaction. Now for making alpha naphthylamine, I took 2.5 gram of alpha nitronaphthalene, 2.6 gram of tin granules, 6 ml of 30% concentrated hydrochloric acid and 4.33 grams of sodium hydroxide. In a flat bottom flask, I added 2.5 grams of alpha nitronaphthalene. Then I added 2.6 grams of tin granules which are flattened with a hammer to increase the surface area. Then I added 6 ml of concentrated hydrochloric acid. Then to start the reaction, I switched on the stirring and heated it on a water bath with a reflux condenser. But still nothing happened, so I had to use a heating mantle. The reaction mixture turned tarry. It was heated for 1 hour. Then to the flask around 100 ml of water was added and the residual alpha nitronaphthalene was steam distilled. Now I prepared sodium hydroxide solution by dissolving 4.33 grams of sodium hydroxide in 50 ml water. This solution was then added to the flask to freebase alpha naphthylamine. More water was also added and steam distilled. It looks like something is going in the distillate as it looks cloudy. I collected 100 ml of distillate and added some table salt. I added the solution into a separatory funnel and extracted the alpha naphthylamine by petroleum ether 3 times. I distilled off the petroleum ether on a water bath and transferred the concentrate into a weighing tube. It was then let to evaporate, but the recovered naphthylamine was so less that I could not even measure. Maybe the reaction wasn't complete, or the petroleum ether was a poor choice for extracting naphthylamine. I should have used diethyl ether. So I again took 2.5 grams of alpha nitronaphthalene and this time instead of tin I added 3.33 grams of iron fillings, reflux for 30 minutes and steam distilled, followed by salting out again followed by solvent extraction by PET ether. This time, concentrated alpha-naphthylamine was more than before, but still it wasn't solid and pure. To it, I added 2 ml of concentrated sulfuric acid for sulphonation and also added some oxalic acid as prescribed in Vogel's. Then I heated the mixture to 180 degrees Celsius for 4 hours. Then I added distilled water to it and stirred with a glass rod. I filtered it but could only see some black mass. To the black mass, I added sodium hydroxide solution and filtered. The filtrate came as a black solution. To the filtrate, I added HCl until the solution was acidic and filtered it. No solid residue was obtained. The reaction was a complete failure. I searched on Science Madness and found that magpie synthesized naphthenic acid by the piria reaction. Piria reaction is a one-step process in which reduction of nitro group and sulphonation takes place simultaneously, but the derived product naphthenic acid is formed as a minor product and the 2,4 sulfonic acid derivative is formed as major product. It was noted that sodium bisulfite is used in 75% excess in the piria reaction. To start things off, I took 6.75 grams of alpha nitronaphthalene that I prepared in the last run, 20 grams of potassium metabisulfite. On adding water to metabisulfite, it converts into bisulfite, and 50 ml of distilled water. I started by dissolving 20 grams of potassium metabisulfite in 50 ml distilled water. Like this, potassium bisulfite solution will be ready. Then to it, I added 6.75 grams of alpha nitronaphthalene. Then I set the flask on a heating mantle with a reflux condenser. I refluxed it for 4 hours, but the solution did not become homogeneous. Maybe due to the absence of strong stirring, reaction is too slow. I didn't had a hot plate with a magnetic stirrer, so I heated it on a water bath and stirred it with my magnetic stirrer. I even added 10 gram of sodium metabisulfite into it, but still the solution remained the same. So I set it again on a heating mantle and heated it such that it only boils a little bit and stirred it with an overhead stirrer. Within 3 hours, the solution turned dark. Then I again put the condenser. For this reaction, I should have used a 3-neck flask so that I could place the overhead stirrer in one neck and the condenser in the other neck. Anyways, it was refluxed for another 1 hour and then steam distilled to take out any unreacted alpha nitronaphthalene. But there wasn't any alpha nitronaphthalene in the distillate. Then the solution was filtered to remove any insoluble material, and then in a large beaker I took the filtrate and to it I added 40 ml of concentrated HCl. This produces a lot of sulfur dioxide, so should be done with precaution and in a well ventilated area or in a fume hood. I checked the pH of it and it was highly acidic, but no precipitate was formed, so I thought reaction had failed and left it. After some time when I came to my lab, I saw a bunch of precipitate which may be naphthenic acid. I filtered it on a Buchner funnel and it appears to be light pink in color. The precipitate was washed with copious amount of distilled water so as to remove any soluble salts and 1 amino naphthalene 2,4 disulfonic acid. After drying, the compounds look similar to the naphthenic acid prepared by Magpie. The final yield of naphthenic acid was 3.9 grams, which corresponds to a percent yield of 45%. Usually, the yield of naphthenic acid by piria reaction is 20 to 30%. I was also surprised to see a high yield in my reaction. Although the product was washed very much and dried properly. So, our first precursor naphthenic acid had been prepared. Now I will be preparing a second precursor benzidine, which is prepared from hydrazobenzene. To make hydrazobenzene, I took 5 ml of nitrobenzene, 10 gram of zinc powder, 10 gram sodium hydroxide and methanol. Then I dissolved the sodium hydroxide in 20 ml of distilled water and transferred the nitrobenzene into a 250 ml round bottom flask. Then I measured out 50 ml of methanol and washed the nitrobenzene stuck in the tube. Then with the help of a powder funnel, I added 10 gram of zinc powder and then transferred the sodium hydroxide solution. Then I washed the beaker with 10 ml methanol and set it on a reflux for 12 hours. After 12 hours, the flask became opaque. I filtered the reaction mixture hot and washed the residue with hot methanol. I transferred the filtrate into a glass bottle with a screw cap and cooled it in the fridge. Small amount of solid was formed which appears orange in color. It was vacuum filtered and the residue looks like this. This is probably not hydrazobenzene but azobenzene. Maybe my zinc powder was old. That's why I couldn't get a good yield of azobenzene or hydrazobenzene. So I tried once again with freshly powdered zinc and replaced the methanol with ethanol. When I added sodium hydroxide solution, this time the reaction became vigorous and the ethanol itself started boiling. When boiling stopped, I heated it on a water bath. Meanwhile, in a 100 ml flask, I scaled the reaction on a 1 ml nitrobenzene scale and replaced the zinc with more reactive aluminium. For reflux, I filled a test tube with water and immersed it in the flask. The solution should turn yellow and then colorless, but it was not happening in either case. I filtered the solution hot when observed that reaction had stopped and washed the residue with hot ethanol. But this was only an oily layer that was formed at bottom and it did not solidify. It was yellow in color. It seems that aluminium hadn't reduced nitrobenzene completely. The reaction mixture of zinc was also filtered hot to remove unreacted zinc. The filtrate was orange in color. On cooling, some crystals were formed. On filtering, they appeared to be yellow in color. This appears to be azobenzene, and yes, it was azobenzene. There wasn't a trace of hydrazobenzene as it did not yield any benzidine. This procedure was given in Vogel's textbook of practical organic chemistry. Then I searched online and I got a PDF of Vogel's. It had two different procedures of making hydrazobenzene. One is by reduction with magnesium in methanol and other was by reduction by devardas alloy and sodium hydroxide. I neither had magnesium nor devardas alloy. Many people have tried making hydrazobenzene by magnesium, but they have got only azobenzene. There is a video of Wibb's lab making azobenzene via magnesium and methanol method. So I thought to try the devardas alloy method. For that I had to make devardas alloy, which consists of 44 to 46% aluminium, 49 to 51% copper and 4 to 6% zinc. So I took 5 gram of copper, 5 gram of aluminium and 0.5 gram of zinc and melted it with my blowtorch. Devardas alloy has a melting point of 490 to 560 degrees Celsius. It was allowed to cool slowly as it reacts with water. After solidifying, it looks like this, and it is very brittle. On hammering, it shattered into pieces. Now I was left with only 2 ml nitrobenzene, so I took 2.4 gram of sodium hydroxide and 2.5 ml of water. Then the 2 ml nitrobenzene was transferred in a flask and to it 20 ml ethanol was added. Then the sodium hydroxide solution was added. Then I added 3 grams of devardas alloy. But since reaction was too slow, I heated it on a heating mantle. But still, due to large pieces, reaction was very slow. So I added 3 grams of devardas alloy powder into the reaction mixture. Now reaction runs smoothly on heating, and after few minutes the reaction mixture looks like mango juice. After 1 hour the foam looked colorless, which means our reaction is complete. The reaction mixture was filtered hot, but due to aerial oxidation, the solution again started turning red. The precipitate formed on cooling was filtered off and it appeared yellow. The precipitate was washed with water and immediately mixed with dilute hydrochloric acid. I warmed the solution in a water bath to 260 degrees Celsius for 15 minutes and it looks like some PPT has dissolved in it. This was filtered and residue was washed with distilled water followed by dilute HCl and again followed by water. The filtrate appears greenish black. To this filtrate, sodium hydroxide solution was added and grey PPT was formed as reported in literature. This PPT is of benzidine, which is prepared by the benzidine rearrangement from hydrazobenzene, which confirms that devardas alloy was successful in reducing nitrobenzene to hydrazobenzene. However, the yield of benzidine was only 0.1 gram, which just stuck to filter paper and I couldn't recover anything. The percentage yield being 5%, my nitrobenzene was finished, but I had 5 gram of azobenzene that I have prepared in earlier attempts. I read online that azobenzene can be reduced to hydrazobenzene by sodium dithionite. So I took all my azobenzene in a 250 ml round bottom flask. Now I added 20 ml of methanol to it. Now I measured 15 gram of sodium dithionite and dissolved it in 20 ml of water. It started bubbling, so I added some sodium hydroxide to increase the pH and stabilize it. Sodium dithionite did not dissolve completely, so I added it as a slurry and transferred the remaining solid with some distilled water. Then it was set on reflux. After 3 hours, reaction mixture turned white. So before transferring the white PPT into a funnel, I prepared dilute HCl. For that, I took 45 ml of distilled water and to it I added 20 ml of 9 molar 30% hydrochloric acid. I then filtered the precipitate after cooling the reaction mixture with vacuum filtration and washed the PPT with distilled water 2 to 3 times. Then I added ice to the HCl solution to cool it and then I added the PPT to the HCl solution with stirring. When all the PPT was added, I heated the mixture to 60 degrees Celsius on a spirit lamp with stirring for 15 minutes. On heating, smell of sulfur dioxide was observed from the reaction mixture, which means that sodium dithionite had not been washed out completely. So I boiled it for a minute to expel all the sulfur dioxide, and then I filtered the solution after it became just warm enough to hold, and then to the filtrate I added sodium hydroxide solution. This time off white PPT was formed. I checked the pH and it was highly basic. I filtered the PPT on a Buchner funnel and washed with distilled water and dried it in a vacuum desiccator. The yield was 0.5 grams, which corresponds to a percentage yield of 11%. As from azobenzene, this much benzidine wasn't enough. I needed to make more. So I went to my college one day and asked my sir for some nitrobenzene. He is very kind, so he gave me 30 ml of nitrobenzene in a bottle. I took out 5 ml of nitrobenzene from it and tried to reproduce benzidine using the devardas alloy. But this time reaction didn't go well as before. I could get only 0.2 gram of benzidine. So I was just tired of making benzidine and thought of giving up or proceeding with that tiny amount of benzidine. One night I found a research paper which claims an yield of 95% hydrazobenzene. It said to use anhydrous methanol, potassium hydroxide, and aluminium to reduce nitrobenzene to hydrazobenzene. So I measured out 2.7 ml of aluminium foil, 27 ml of methanol, 5.125 ml of nitrobenzene, and 16.8 gram of potassium hydroxide. I transferred the potassium hydroxide pellets into a 250 ml round bottom flask and dissolved it in methanol. Sodium hydroxide cannot be used here due to its poor solubility in methanol. After potassium hydroxide had dissolved, I added the nitrobenzene into the flask and then added the aluminium. After adding all the aluminium, I set it on a reflux on low heat. After some time, reaction subsided and the reaction remained red even after refluxing for an hour. I took out the flask and added some devardas alloy powder and then set it on reflux. But still, yellow color of solution was not fading. It means that nitrobenzene has been reduced to azobenzene, but azobenzene is not being reduced to hydrazobenzene. It is understandable as aluminium needs water to react with potassium hydroxide to produce nascent hydrogen, and we haven't added any water to the reaction mixture. So I added 1 ml of water from the top of the condenser, and after 15 minutes the yellow color of reaction mixture faded completely. The hot reaction mixture was poured into ice cold water containing small amount of sodium bisulfite. White PPT of hydrazobenzene was formed. The residue in the flask was washed with methanol and transferred in the beaker. Then the PPT was vacuum filtered and mixed with dilute HCl and then placed on a hot water bath for 15 to 30 minutes. The residue was filtered off while hot. In the filtrate, crystals of benzidine dihydrochloride were formed. The residue was washed with distilled water and the filtrate was transferred in a beaker. To this filtrate, sodium hydroxide solution was added until pH was alkaline. And the PPT formed was vacuum filtered, washed with distilled water, and dried in a vacuum desiccator. The final yield of benzidine was 1.8 grams, which corresponds to a percentage yield of 37.5%. On the left is 1.8 gram of benzidine prepared by this method. In the middle is 0.5 gram of benzidine prepared from dithionite method. It looks a bit different color, and on the right is 0.3 gram of benzidine which was prepared by devardas alloy. I checked the TLC of the left and the middle compound and found that both had same RF values, meaning that both are same compounds. Now to make Congo Red, I measured out 1.6 gram of benzidine, 1.24 grams of sodium nitrite, 2 ml of concentrated HCl and 12 ml of water. I transferred the benzidine in a beaker and added the HCl onto it. Then I added distilled water to it and stirred it. I added additional 2 ml HCl to it and dissolved the sodium nitrite in 7 ml of water. After benzidine dihydrochloride solution was ready, I added ice to both the solutions and then added the sodium nitrite solution to benzidine dihydrochloride solution. Slowly, drop-wise with stirring. After the addition was complete, I dissolved 3.9 grams of naphthenic acid and added 4 ml of 10% sodium hydroxide solution followed by 10 ml of distilled water. After the naphthionate solution was ready, I added the tetraisotized benzidine dichloride solution into the sodium naphthionate solution with constant stirring. The pH of the solution was around 5 to 6, so it was made alkaline with 3.5 grams of sodium carbonate. I transferred the reaction mixture into a bigger beaker and then rinsed the small beakers with sodium carbonate solution and then transferred in the bigger beaker. I again checked the pH and it was still neutral, so I added some 10% sodium hydroxide solution to make it alkaline and checked the pH. This time it was around 9. It was kept at room temperature for 24 hours and then placed on a hot water bath at 60 degrees Celsius for 1 hour. I checked the reaction mixture by taking a small amount of it in dilute sodium hydroxide solution and red color was formed, which on acidification with sulfuric acid, violet color solution was formed. It is similar to that of Congo Red prepared by Magpie, but as far as I know, Congo Red is blue in acidic medium. I vacuum filtered the reaction mixture to remove the insoluble tar and washed it until filtrate was only light red in color. To the filtrate, 40 grams of sodium chloride was added to precipitate Congo Red as disodium salt. It was stirred for some time and then vacuum filtered. The residue is Congo Red with high impurity of sodium chloride. It can be further purified by dissolving the Congo Red in hot ethanol and evaporating the ethanol to dryness to recover pure Congo Red. But I had no ethanol left and the sodium chloride impurity wouldn't matter for me, so I dried it in a desiccator. It was highly impure, so I did not calculate its yield. Now I dissolved some Congo Red in water and as you can see, a dark red color is formed. In first beaker, I have a dilute solution of sodium hydroxide and on the right I have a dilute solution of sulfuric acid. I added few drops of Congo Red to these solutions. The left solution turns red while the right solution turns a dark violet color. Now I took a litmus paper and dip it in the red solution and it turns blue. And when I dip it in blue solution, it turns red and it turns back to blue in red solution. The same experiment can also be performed by this pH paper and it looks pretty cool, right? So that's it for now. Thanks for watching my video. Please rate, comment and subscribe to my channel. If you like my work, you can support me financially through PayPal. It would help me buy new equipment and chemicals.